Okay, we're going to find the vertical asymptotes and y-intercept of this function right here, the reciprocal of that function, so we put that down. This is what we're trying to find the asymptotes and y-intercept for. So the first thing I got to do is factor that. Now this might take a little bit of effort here, but at least 3 is prime, so I know it's got to look like that. And 5 is prime too, so this is either got to be 1 and 5 or 5 and 1. But if we put 1 and 5 here, when I expand that out, I'm going to end up with 15, 3x times 5. So the 5 has to go with this term, it has to be a 1 here. So I'm going to want that to be plus 5 minus 1. That way I'm going to get 3x times negative 1 will be negative 3x plus 5 will give me the 2x in the middle. Basically, I'm just guessing and checking. Okay, and I can do that because I've got prime number at the beginning, prime number at the end. There's just not a lot of choices for what it could be. So my vertical asymptote here is going to be related to the non-permissibles here. 3x plus 5 cannot be allowed to equal 0, which means, okay, if 3x plus 5 can't be 0, that means 3x can't be negative 5, x can't be negative 5/3. That's one of my vertical asymptotes. The next one here, x minus 1 can't be 0, which means x can't be negative 1. So that means my vertical asymptotes here are going to be x equals negative 5/3 and negative 1. Now, the y-intercept is so easy to find because you just look at the original function. The y-intercept of the original function is going to be negative 5. Okay, those two terms will just be disappear. So the y-intercept will be negative 1/5. Whoops, can't see that. There it goes. Okay, let's say it again. Negative 1/5.